All right, so now that we have that, let's go ahead and run this real quick so we can see how it looks on the phone or our emulator real quick here. Very nice. It looks really nice. It's in the middle, and yay, we're doing great. So now let's go ahead and put together the code that will give us this animation that we need. Okay. In Compose, we have access to a lot of different kinds of animations, and that's the beauty of Compose. In fact, I could create a total different course just on animation. But we're going to use a subset of this animation. So the idea is that we're going to be scaling up and down this entire structure here, this entire logo. And then after a few milliseconds, we're going to jump onto the next screen, which is going to be the login screen. So how do we create this structure of animating our logo in this case? So I'm calling logo, this is what I call it, a logo, essentially all of this surface. So essentially what we want to be able to do is to scale up and down, right, this surface here, which is indeed our logo. To do that, we need to have some sort of animation. Now, how do we animate something? Well, in this case here, we are going to use a different block here called LaunchedEffect. So I'm going to say LaunchedEffect as such. Okay. And if you look at it, it is actually part of the Compose runtime. So if you scroll down, it's going to say when LaunchedEffect enters this block, when LaunchedEffect enters this composition, it will launch block into the composition's coroutine context. The coroutine will be cancelled and relaunched when LaunchedEffect is recomposed with a different key. So coroutine in this case, what we're saying is that we want to stay away from the main thread because we don't want to bog down the main thread, which is solely for the user interface, for drawing the user interface. So we're saying we're going to launch this in a separate thread per se. There's more to that, of course, but that's the essence of all of this. So I'm going to say launched effect as such, and I'm going to say true for the key and for the block, because I know the block is also the last function parameter of LaunchedEffect. I can actually use the trailing lambda, and you can see indeed I have inside here the actual coroutine scope, which means we can run code here that requires to be outside of the main thread, if you will. All right, so in this case here, I'm going to use a variable to scale things down to a certain value. But for that, I'll have to create, yes, because it's going to be a state, I'm going to create a variable called scale as such. I'm going to make it a remember animateTo like this. Get the animateTo compose like that. And I'm going to add the initial value here of 0f floats. Okay, so this is going to be the scale factor, and initial value is going to be 0, and it has to be a float. Okay, so we can use that value inside here. So now I can say scale dot, and we will say animate or animateTo. I can animate to decay or animateTo. So in this case here, I need to pass the target value and the animation scope and so forth. And you can always come down here and start reading what this animateTo does. So it says it starts an animation to animate from a value to the provided target value. The target value here, we can play with this, but target value is going to be, I'm going to say 0.9f. Okay, and I'm going to pass here the animation specs. So the idea is that what kind of animation I'm looking to do. Well, there are a few. I'm going to use the tween animation there as a function, and then this requires a few parameters also. So the duration, so how long this animation will last. In this case, I want 800 milliseconds, so less than a second, right? And I can pass the easing, so the elasticity of this animation. Okay, and in this case here, it's a lambda. I'm going to say I want to use the overshoot interpolator, and for that I need to pass the tension. I'm going to say tension that I need 8f, and then I'm going to say dot get interpolation, and pass in the IT. Now, a lot of code here. All we're doing really is that we are creating the actual animation. We pass in the animation spec. Obviously, the target file is going to be 0.9. Our animation spec, here we pass the tween and we say how long this animation will last. It's going to be 800 milliseconds. And we pass the easing, the curve that will be used to interpolate between start and end values. And of course, we have our shoot interpolator, and pass attention, and the get interpolation, pass the IT, which is this float that we get in our easing lambda. So all of this is actually given by the framework. If we had to do this manually ourselves, well, we would have to do a lot of work. So that's one of the powers that we get from using Compose. All right, and next here, what I need to do, still inside of our LaunchedEffect, right? This is, think of it as a different lane. I'm going to delay this. I'm going to say delay, right? I can pass time millis or duration. Just time is millis, fine. And I'm going to delay this for about 2000 long, which in this case 2000 milliseconds. So this is about 2 seconds in this case. We've created the scale animate table there. Initial value is 0, and we know that the target is going to be 0.9. Okay, these are floats, of course, and now the scale here is going to change its status or its state as this animation happens. So this scale needs to be called somewhere. Just like with any other surface or any other composable, we can actually attach the scale, right? The scalability or the scale of our surface. Look at this inside of our modifier here. So we have a surface, which indeed we're talking about this whole logo here, as I call it. We can actually go and say something like this, dot scale. So we can scale this surface here, this composable. And what are we going to pass? Well, we're going to pass scale value dot, actually scale dot value, like this for our scale. So as the animation happens, this surface here will also get the value of our state, right? And then change accordingly. So this entire surface now should adhere to our animation. Is that true? Well, let us see. I'm going to run. Let's look at our app here. If all goes well, we should see that scaling animation happening. And there it is. Okay, it works. Let's do it again because we worked so hard for it. And voila. Obviously, you can go ahead and change these values to your liking, and you can research more about animation Compose, and there's a lot you can do. This is just scratching the surface, but at least we have something decent that users hopefully get delighted by.